Okay, so now let's look at the three-dimensional plotting. So MATLAB also offers a variety of 3D plots. Okay, some of the examples are the line plots, the surface plots, and also the contour plots. The 3D plot can be created using the plot3 command. The function plot3 is the 3D version of the plot command. The command plot3 followed by the input arguments, so you have to remember that you need three different vectors for the input argument. Okay, so this command will draw a 2D projection of a line in 3D through the points that these coordinates are the elements of the vectors of x, y, and z. So let's try this example. First, let's create a vector x, okay, by using the linspace. 0 is the initial value, 10 pi is the final value, and we want it to create 1000 elements of this range. And then we have vector y, and then we have vector z sine x. Use plot3 command followed by the input argument of x, y, and z. Turn on the grid and then put labeling for each axis. So for the x axis, I want to label it as angle. Y, label it as cos x, and z label as sine x, and I'll put the title for this graph as a spring. Then I run the section. Okay, so you will get this spring, which is a 2D projection of the line in 3D, in 3 dimension. Okay, so this is x-axis, this is y-axis, and this is the z-axis. Okay, just for fun, you can try this Comet3 function. It is similar to plot3 except that it will draw with a moving comet head. Okay, so we will use the previous command, okay, but instead of plot3 we change it to Comet3 and then run. So okay, so it is kind of animated. Okay, so if your animation draws too slowly, you can add more data point. Okay, for example, here you can add more data point and try run. So if okay, restart. Okay, you can see that it moves quickly, okay, than previous data point of 1000. Okay, another type of 3D plots is the surface plots. Okay, so surface plots, it used to represent the XYZ data as a surface. So we have MATLAB have two different surface plots. Okay, the first one is a mesh plot, which draws a surface as a wireframe. Okay, this is an example of a wireframe surface drawn using the mesh command, and the surface plot which generate a facet view of the surface in color. Okay, let's try this example. First, you define this matrix Z, and then you use the command mesh Z, okay, to create the wireframe surface, and then you include the labeling for X, Y, and Z. Okay, so just simply label X, and then you can copy and paste it here, and make sure you change the corresponding label. Okay, and then you run the section. So this is the example of a mesh plot. Okay, let's try the surface plot. Okay, but before that, you can also use mesh with 3 variables. Okay, here previously, okay, this one, the X and Y was based on the matrix dimensions, but when you want to use the mesh plot with 3 variables, you have to know the values of X and Y that correspond to the Z values. Okay, so we can plot against the values of X and Y instead of the index number. Okay, so with this we use the same input of matrix Z, except that we want to create vector X using the linspace 150, 10 elements, and a vector Y also use the linspace. Okay, starting value, final value, number of elements. Run this section. Okay, okay, I add the command figure here is for me to open 2 different figures. Okay, so figure 1 and figure 2. Okay, next let's look at on the surf plots. Okay, so surf plots is similar to the mesh plots. Okay, so we will use the same command but change from mesh to surf. Okay, basically we will create this colored panel. Okay, you will get this graph using the command surf. The syntax is the same, okay, either the mesh and the surf plot. Okay, so both of the surface plots, okay, there are several shading options available. Okay, for example, this is the example of the default shading, and this is when the shading is flat, and this is when the shading is interp. Okay, this is the specification of shading options. You can just adjust the color scheme by using the color map function. Okay, how you can use to adjust the color scheme? Okay, first you have to know what are the color map options. available. Okay, so to do that, you can type help color map on command window. Okay, then it will give you a list of the available options. Okay, for example here, help color map. Yes, you type this help graph 3D. Okay, and then you will see the available color map options. Okay, for example, you can click on the autumn and it gives you the description of the autumn, which is the shades of red and yellow color map. And then you can try this out. Okay, so figure is for us to create a new figure, so I'm going to use the surface plots. Okay, I'm going to plot a pix function and then set the color map as color map winter. Okay, and then click run, so you get this color map winter. So you can try, maybe you want to try color map prism. Yes, this is an example of color map prism. Okay, so let's continue. Let's see the contour plots. Okay, contour plots use the same input syntax as the mesh and surface plots. Okay, so the contour plots will create graphs that look like the contour maps used by the hikers. So to demonstrate this function, I will use the subplot command, and then we are going to create all these different mesh, surface, contour, and also the combination surface and contour plot. So you can pause this video and then type all these commands. Okay, so I'm just going to skip right to the final commands as I have it here. Okay, so first you will have to define matrix x and y, and then you use mesh grid function, okay, to map this x and y value. Okay, and then you create, okay, because this is a row vector, so you use mesh grid function, okay, to map it into a 2D matrix. Okay, and then you define matrix Z. Okay, so here it have, for you to create contour plots, you have to have these three data x, y, and z. Okay, so I'm going to use subplot, so you have to define it one by one. So for the first plot is the mesh plot, second plot is surface plot, third plot is contour plots, and this is the combination of surface and contour plots. So when you hit the run, so you will get this example. Okay, so next we also have the pseudo color plots. Okay, it is actually quite similar to the contour plots, but instead of lines, we use a 2D shaded map. It also uses the same syntax as the contour plot. So this is the example that use the built-in MATLAB function pix, okay, to display the difference between the pseudo color plots. The pseudo color plots is the 2 to 1 here. This is the pseudo color plots. Pseudo color plots. But with different shading. Pseudo color plot with different shading. Okay, so this is the XYZ is the built-in MATLAB function pics. Okay, so the first subplot 2 to 1 is the pseudo color plots. And then for the second plot here, okay, subplot 2 to 2, we deleted the grid. Okay, first plot had these grids, so the grid is deleted when it is when we use the interp is referring to the interpolated shading. So when we use the interpolated shading, it remove the grids. Okay, next we add contours to the image by overlaying a contour plot. Okay, so hold on, so we are going to edit contour to the plot. Okay, maybe this is more clearer. Yes, for 2 to 3, okay, this is the original plot, and then we lay this contour plot on top of this interpolated shading pseudo color plots. Okay, so we get this 2 to 3 subplot, and then for the final plot, which is in the subplot 2 to 4, we only create a simple contour plot, okay, added to this subplot just for you to make the comparison. And then finally, when you already done creating all your graph and figures and plots, okay, you need to know how you can save, print and export those figure files. Okay, as usual, when you create your MATLAB commands in M file, you can run it. Okay, you can rerun it. Okay, to recreate a plot. Okay, alternatively, you can also save a figure that you generated. For example, this is the figure that is being generated after you run the M file. You can save as, and then save it as figure. For example, this is figure pseudo plots. Okay, save it as .fig extension type. So when you can browse your current folder and you can reopen the figure that you generated again. Okay, and to print the graph, okay, you can print everything inside the figure window frame, including the axis label. Okay, to print, for example, this is the figure label. To print it, okay, just click this print figure or from the file menu. Okay, print, and then you can change the setting. Okay, the setting is based on your computer. You can also print it to the PDF. Okay, this is when I try to print it to the PDF, and then you can change the properties of the page setup, okay, depending on your preference. So if you have a black and white printer, okay, the color lines and text appear as gray, which may not print very clearly in some cases. So in that case, you can select page setup from the figure file menu. and then select the lines and text tab, and then click on the black and white option. Okay, so on the third tab, okay, choose color tab and then select the black and white for lines and text only. Okay, or you can choose the color scale as grayscale, but it's very hard to differentiate. Alternatively, you can export the graph, okay, by copy the figure. So file, you can from edit, copy figure, and then you can open your Word file. For example, you can open your Word file and then copy it to the okay, like this. Okay, copy it to the Word file. Okay, but maybe you have to adjust the figure settings first. Okay, so to do that, you can select preference from the figure files menu. Okay, and then you can select figure copy template preference, this one, and copy option preference to adjust the setting. Okay, maybe you want to use the figure color, force white background, okay, whatever setting that you want to change. Okay, okay, that's all for the summary. Okay, we have looked at how we can create 2D plots, which is the most commonly used plot in science and engineering. Your graph should always include titles and axis labels. The axis labels should include units, and MATLAB include extensive options for controlling the appearance of your plot. You can create multiple plots in the same figure window, and there are also a variety of other types of 2D plots and 3D plots. So except from modifying or adding labels, text, legends, and so on from the using the command prompts. Okay, by typing the commands, you can also modify the plots interactively using the menu bar. And the figures created in MATLAB can be stored using a number of different file formats. Okay, that's all for chapter 2.